Alright. Day 23 of becoming a full stack developer in 8 months. Today we're starting with the articles where we left off yesterday, and we just have 2 articles and 2 videos, and with that we will be closing the advanced grid section. So without losing any more time, let me jump straight into it. I'll probably get rid of this to do so I can see better. Aside anything else, yeah. Alright, I'll probably leave it at that. Yo, Supreme Overload, it's morning at my end of the world. Good morning, bro. It's morning for me as well. It's 6:30 a.m. for me. What is the time for you? Thank you for joining the stream, my brother. As always, appreciate it. I don't know how you're doing it. That tastes awful, not going to lie. 6:30 also, wow. Where are you from if you feel comfortable? I'm from Bulgaria. Lemon and lime flavor it says, but it just tastes terrible. And why are you up so early as well? Happy Monday. So they're saying the article is on auto-sizing columns in CSS Grid, auto-fill versus auto-fit. Ghana in Africa, wow, so crazy. Wow. And it's the same time. Oh my. Cool. One of the most powerful and convenient CSS Grid features is that in addition to explicit column sizing, we have the option to repeat to fill columns in a grid and then auto-place items in them. More specifically, our ability to specify how many columns we want in the grid and then letting the browser handle the responsiveness of these columns for us, showing fewer columns on smaller viewports and more columns as the screen state allows for more, without needing to write a single media query to dictate this responsive behavior. Oh no, it's 4:30 rather. So it is 4:30 for you in the morning. And why are you up so early? Wow. Don't tell me you're just waking up for the stream. Don't, please. We're able to do that using just one line of CSS, the one-liner that reminds me of when Dumbledore just waved his hand at Horace's apartment and the furniture flew back to its original places, ornaments reformed in midair, feathers zoomed into the cushions, torn books repaired themselves and they landed upon their shelves. Not slaves, sorry. This magical media query-less responsiveness is achieved using the repeat function and the auto placement function keyword. It's still very early for me, I can't even read. To summarize, the repeat function allows you to repeat columns as many times as you need. For example, if you're creating a 12 columns grid, you could write the following one-liner, repeat 12 times one fraction each. The 1FR is what tells the browser to distribute the space between the columns so that each column equally gets one fraction of that space. That is, they're all fluid, equal width columns, and the grid will, in this example, always have 12 columns, regardless of how wide it is. This, as you probably have guessed, is not good enough, as the content will be too squished on smaller viewports. So you need to start by specifying a minimum width for the columns, making sure they don't get too narrow. We can do this using the min-max function. I'm used to waking up this early. I also had to finish certain tasks before the day fully began. Yeah, I feel you. I'm doing this because I want to do it before work and get the important stuff before work. So I totally understand. Good on you for waking up that early. But the way CSS Grid works will cause overflow in the row. The columns will not wrap into new rows if the viewport width is too narrow to fit them all with the new minimum width requirement, because we're explicitly telling the browser to repeat the columns 12 times per row. To achieve wrapping, we can use the autofit or autofill keywords. These keywords tell the browser to handle column sizing and element wrapping for us, so that the elements will wrap into rows when the width is not large enough to fit them without any overflow. The fraction unit we use also ensures that in case the width allows for a fraction of a column to fit but not a full column, that space will instead be disturbed over the column or columns that already fit, making sure we aren't left with any empty space at the end of the row. At first glance of the names, it might seem like autofill and autofit are opposites, but in fact the difference between is quite subtle. Maybe it seems like you're getting extra space at the end of the column with autofit, but when and how? Let's take a look and see what's really happening under the hood. Fill or fit was the difference. In a recent CSS workshop, I summarized the difference between autofill and autofit as follows. Autofill fills the row with as many columns as it can fit, so it creates implicit columns whenever a new column can fit. Because it's trying to fill the row with as many columns as it can, the newly added columns can and may be empty, but they will still occupy a designated space in the row. Autofill fits the currently available columns into the space by expanding them so that they take up all of any available space. The browser does that after filling that extra space with extra columns, as with autofill, and then collapsing the empty ones. This may sound confusing at first, but it makes a lot more sense when you visualize the behavior, so we'll be doing exactly that with the Firefox Developer Tools Grid Inspector helping us visualize the size and position of grid items and columns. Consider the following demo as an example. What a guy, keep going man, true inspiration. Thank you so much, Index. Wow. And if you subscribed, thanks so much as well. I just saw someone subscribe. Really appreciate you guys. So I don't have the developer tools, but I kind of understand how that's working. I don't know why. This is the resize. Alright, so autofill at the top. Autofill at the top. And it seems, wait, okay. Like, I understand the difference, but in that example they seem to be doing the same thing. The columns are defined using the repeat function and have a minimum width of 100 pixels and maximum set to 1 FR, so that they would expand and equally share any extra space when it's available. As for the number of columns per row, we're going to use the auto placement keywords, so that we'll let the browser take care of the responsiveness of the grid, and we'll wrap the columns into new rows when needed. The browser will place and size the columns in the first example using the autofill keyword, and we use autofit for the second. Up to a certain point, both autofill and autofit show identical results. Maybe so it was just too narrow. But they don't have identical behavior under the hood. It just so happens that they will give us the same result up to a certain viewport width. So I guess up until they're all on the same row, they will give us the same behavior. The point at which these two keywords start exhibiting different behaviors depends on the number and size of columns defined in grid template columns. So it will differ from one example to another. can we just go into the CSS and no, I actually have to go to the HTML and delete some of these so we can better see it. So I'll leave just 3 divs. Oh, I cannot. Let me edit it on Comeau quickly. Alright, but then I cannot resize it anyways. We learned about this in yesterday's lesson, so I just want to share it. The difference between these two keywords is made apparent when the viewport gets wide enough to fit one or more extra columns into the row. At that point, the browser is presented with 2 ways to handle the situation, and how it handles it is largely depends on whether or not there is content to be placed into that extra column. So when the row can fit a new column, the browser goes like, I have some space to fit a new column in there. Do I have any content, in example grid items, to go into that extra column? Yes, okay, all good. I'll add the column into the row and I'll wrap into a new row on a smaller viewports. And second, in the case where there is no content placed into the new column, do I allow this new column to occupy space in the row and therefore affect the position and size of the rest of the rows, or do I collapse that column and use its space to expand the other columns? Autofill and autofit provide the answer to that last question in particular and dedicate how the browser should handle this scenario. To collapse or not to collapse, that is the question, and that is also the answer. Whether you want it to collapse or not depends on your content and how you want that content to behave in the context of a responsive design. Let's see how that works. To visualize the difference between autofill and autofit, take a look at the following screen recording. I'm resizing the viewport enough to create horizontal space that's enough to fit 1 or more columns into the row. Remember that these 2 rows are identical and have the exact same of content and column number. The only difference in this demo is that I'm using autofill for the first one and autofit for the second. Alright, so if we take a look at this, you see how autofill makes new columns when they jump, but it doesn't collapse them, or it doesn't fill them with content. And this just makes the columns bigger, which I think is more responsive, but I guess it depends on the use case since we have both of them. Notice what's happening there. If it's still not clear, the following recording should make it clearer. So there we have it with the column numbers. See how it creates new columns? That's a perfect example. Alright, autofill behavior. I'll fill that row up, add as many columns as you can. I don't care if they're empty, they should still all show up. If you have enough space to add a column, add it. I don't care if it's empty or not, it's still occupying space in the row as if it were filled. Wow, autofill fills the row with as many columns as it can, even if those columns are empty. Autofit behaves a little differently. Autofit does too, fill the row with more columns and the viewport width increases, but the only difference is that the newly added columns and any column gaps associated with them are collapsed. The grid inspector is a fantastic way to visualize this. You notice that columns are being added when you keep your eye onto the grid line numbers, which will increase as the viewport width increases. So if you can see here, I don't know if you can see, but we're still adding new numbers, but they are at the back. So 7 and 8 are still the end column, but we have more columns, but they're collapsed. So I was just wondering what will happen if we position an item, let's say between line 3 and 4. As we get new columns, will this item stay like the same width and the other will get bigger, or what will happen, but it seems like there will be no difference because the end columns, they just collapse. Alright, let me drink that. I have to make a coffee and throw that in the bin. It's awful. Auto-fit behavior: make whatever columns you have fit into the available space, expand them as much as you need to fit the row size. Empty columns must not occupy any space. Put that space to better use by expanding the field, as in field with content or grid items, columns to fit the available row space. A useful tip to remember here is that columns added in both cases, whether collapsed or not, are not implicit columns that have specific meaning in the spec. In our case, we're creating columns in the explicit grid in the same way as if we declared you wanted 12 columns, for example. So column number -1 will work to target the end of this grid, which it doesn't if you are creating columns in the implicit grid. Props to Rich Andrew for this tip. Xander, thank you so much. Good morning, my guy, or evening, whatever time it is for you, but thank you for tuning in. So we have the summing up. Finally, the difference between autofill and autofit for sizing columns is only noticeable when the row is wide enough to fit more columns in it. If you're using autofit, the content will stretch to fill the entire row width, whereas with autofill, the browser will allow empty columns to occupy space in the row like their non-empty neighbors. They'll be allocated a fraction of the space even if they have no grid items in them, thus affecting the size width of the latter. Which behavior you want or prefer is completely up to you. I have yet to think of a use case where autofill would make more sense than autofit. Do you have any use cases? If you do, please feel free to share them in the comments below. So exactly what I was saying, like I don't know where autofill will be used. I saw autofit as more responsive, and it seems like the author of this article thinks the same, but again, I think this is from 2017, so there might be use cases now. Alright, with that said, we have to watch 2 videos, and after that we have one more small article, so let's begin with that. I have a perfect pose of this guy's face. It was the perfect moment to pause it. Alright. Oops, no audio, sorry.
Here at my channel, hi there, my name is Kevin, and here at my channel we learn how to make the web and how to make it look good while we're at it with weekly tips, tricks, and tutorials. And I'm really excited about this week's video because we're going to be looking at a really cool feature of the CSS Grid. It's when we use the repeat syntax. If you're familiar with it, when you do repeat, you can say like repeat 3 and then comma and say 1FR, and it's going to give you 3 columns that are that size. Just like that, so you don't have to write like the column widths over and over again if they're all the same. But there's this really neat feature that's included in the repeat, which is the autofit or autofill. It sort of makes making responsive stuff a lot easier, less media queries, really awesome, but they work really similarly, and sometimes it's hard to even know what the difference is. So that's what this video is about. It's exploring autofit and autofill, how they work, and what's similar about them, but also what's different about them. But right before we jump into it, you're going to notice my setup in this one's a little bit different. I'm going to refer to a previous video that you might not know about, and I might even say once or twice to go in the code and try things out yourself, and you might be wondering what's going on. If you're curious about more information and all that, at the end of the video, I'm going to be explaining a lot more about what's going on there. So let's dive right into it.
Alright, let's begin.
So this is
oh my god, they have an ad, sorry.
Coding is writing, but it's not just math and numbers.
Every time I talk about something with Grid, I get so excited because there's so much cool stuff with Grid, and this is one of those things. When we're using the repeat like we were just looking at, instead of using a set number of times like we just did, we had 3, so we did 3, 1FR. Instead of the 3, we can use 2 keywords. We can use autofit or autofill as well. The 2 of them are different, though the differences can be confusing at times. So I'm going to try and explain it, but then it'll be a lot more clear, I think, once we actually look at it. But autofit will fit the columns you've defined into the available space. It's a little bit more complicated what's actually going on, but essentially this is what it's doing. Whereas autofill will keep adding in new columns even if they're empty. Are you confused? Let's go take a look, because as I said, I think it'd be a lot more clear. So here, where we have my grid template columns, I can replace this with either autofit
They
or
just don't take up any
autofill.
space.
So I'm going to start with the autofill here, and I'm going to do autofill, and I'm going to give it a min-max, because without the min-max, it doesn't really do much. I'm going to give this a minimum size of 200 pixels, comma 1 FR. This is, generally speaking, the large size. You're going to want to give it 1 FR, and you will want to give it a minimum size. If not, the autofill won't really be doing its magic. So let's go take a look, and right now, it effectively looks the same. Nothing's really changed. But watch this, as I get smaller, before, just remember what happened before actually. When I got smaller, at one point we'd hit my minimum size. So my minimum size right now is 200. So it'd be 246 plus our gutter spacing there. That would just stop, and then I would get side scrolling, right? Now, what just happened? Oh my goodness. Well, now I have a 2-column layout. Now let's keep going. Let's keep going. Now, oh, I get excited still, and I've played with this a lot. Now I have a 1-column layout. I don't have a media query in here. It's just magically working. 2 columns, 3 columns, 4 columns. And if we go wider, we get 5 and 6 columns. And everything's just automatically flowing. And
I just noticed, or I thought of a use case. You can use it in like an e-commerce catalog page, or where you show all the available items in an e-commerce store. This will be very neat for there.
going where,
Like imagine every project title like it's a product, and depending on the viewport you can say how many columns you want
it needs to
with
go.
products.
Isn't that really cool and really fun?
That's really cool.
I think that's so cool. So what it's doing is it's saying that it has a minimum size of 200 pixels and a maximum size of 1 FR. Right now, these are growing to fit the available space, but it knows the minimum size these are allowed to be is 200 pixels. So when we get to here, if we can fit 3 of them next to each other using that minimum size of 200 pixels, it's going to squeeze them in. So they shrink in size to their minimum, and they all squeeze in next to each other. But then we're allowed to grow, we're allowed to grow, we're allowed to grow. But then, boom, once that minimum size can squeeze down again, and we can fit 4 of them, it's going to do it automatically. That's just so much fun. I think that's so cool. Now, if I switch this to auto fit right now, you won't see a difference. It's going to work exactly the same. Because of how this is laid out, there's not really anything that's going to change in it. So what I'm going to do to illustrate this a little bit better is we're going to leave only 2 portfolio items, and we're going to take all of these other ones off. I'm just going to delete all of those, and I'm also going to come up here and I'm going to comment out my title, because my title is going to cause some problems with it with how I've set this up to really illustrate what the difference is. So we're at here, we have my autofill and min-max of 200 and 1 FR. Let's go back here for a second and say autofill will keep adding in new columns even if they're empty. So let's go take a look. We're going to refresh here, make sure we're on a blank slate, and let's shrink down. So we have my 1 column, they're stacking, we know that already. Oh, we have room for 2 of them to go next to each other, they will. But here now, this is where we have the new columns will come in even if they're empty. So there's no content to put in this cell, but it's still going to create it because it's adhering to that min-max I said. So now we have 200, 200, we had room for another 200, it's going to fit it in there. We have room for another 200, it's going to fit it in there. Let's bring this back down to like this, and let's switch this to auto fit instead. So auto fit, instead of adding new columns, even if they're empty,
It will make them just a
fit
lot
the
bigger.
columns you've defined into the available space. And yes, it's more complicated if you actually look up with the spec, but essentially, this is what it's really doing. So as long as that's how you see it, it's all good. So here we have my columns like that. They're going to 1 column, then we go up to 2, but they're going to stay 2 forever now, because I don't have any
There is
extra
no more
content to add in there.
content.
Auto fit I find a little bit more useful in that if I only have 2 items, it's not going to all of a sudden start adding in these random empty columns that I'm not using. It's just going to let my content grow. So it becomes a little bit more versatile. I could use that in different situations, whether I have 3 items or 10 items, and it's always going to work. Whereas the other one, sometimes if I was using it in an area with 10 and it was working well, I might bring that same class down to make 2 columns, but it's going to break it here because then I get all these extra little columns squeezing in. There will be situations where both of them will come up though. So that's the difference between autofit and autofill. If it seems a little bit weird, play around with it a bit in here, make sure you understand it, because it's a really subtle difference, but it's a really important difference as well. So I hope you enjoyed that lesson, and the reason that lesson was a little bit different is it's actually a sample lesson from the course I'm currently building.
We have a big
Change
outro.
what's there, it happens in the preview window, it's all just happening right there. A lot easier for people to learn and to practice and to...
Alright, thank you so much. Wait, let me check something out. Odin. We have no comments from the Odin project on this one. Or they haven't voted actually. Let me check. Yep. Oh, there are some Odin project comments. Nice. I noticed as you get further and further into the course, you see less and less comments on YouTube from people on the Odin project. Oh, there's my live stream. Is it? Ah, no. I don't know why it says day 22. I see it is day 23. Alright, anyways.
Represents
Let's
grid two-dimensional.
bring that back and put it on full screen. I think this will be a good video. Learn CSS Grid, a 13-minute deep dive.
I can place things on it horizontally, vertically, and both simultaneously. Actually, I can position items in any way I want, even stacked. Each number represents a line. These lines are row lines and these lines are column lines. Our grid is made up of cells. Each square is a cell. And finally, our grid is also made up of tracks. These are the rows and these are the columns. Creating a grid starts in the HTML. We need a container and some items inside of it. The container is a div with the class of container, and the items are divs with the class of item 1, 2, and 3. In our CSS.
Yes, the more we progress, the less likes from the Odinites. And if you go to the last project, like in JavaScript or Ruby, you see that there are less than 100 submissions, like 2-digit submissions. In the beginning there are like thousands of it, but the final projects don't even have 100 submissions from the users. And I'm committed to submit the last projects as well, so we'll be one of the few.
CSS, we give the container the display of grid. We see nothing happened, but this is because we need to tell grid how many rows and columns we want defined. To define rows and columns, we use the grid template rows and grid template columns properties. They work by defining a track for each value that you pass it. If I give 100 pixels to the columns, now I have one column of 100 pixels. If I add a second value of 100 pixels, now I have two columns of 100 pixels, and so on.
Okay.
I'll copy the values from my grid template columns and paste them in the grid template rows. Now I have a grid with 6 rows and 6 columns, and all of the cells have the same size. If I want to position an item, I can select it and give it the grid row start, grid row end, grid column start, grid column end properties. Inside of each will go some line numbers. Let's say I want item 1 to look like this. Then that means item 1 starts on line 1 of both the rows and the columns. We also see that item 1 ends on the 3rd line of the rows and ends on the 5th line of the columns. The other two items were pushed because we aren't explicitly defining their position. Writing these 4 properties each time you want to position something is a bit much. You can instead use these 2 shorthand properties, grid row and grid column. Like
and
the
then
other
to make it even
properties,
shorter,
these
grid
also
area.
take inline numbers as values. The first value is the starting line, the second is the ending line, and they need to be separated by a slash. I want my second item to span 2 rows and columns. I could give it a grid row of 1 and 3 and a grid column of 5 and 7, and this works amazingly, but an easier way to achieve this is with the span keyword. Instead of the values that I currently have, I can just use the span keyword with the number of cells that I want to span. Basically, the span keyword is saying from wherever you currently are, span yourself this number of times. This is easy to read and is also why a lot of people love the span keyword, but the main downfall of using this is it doesn't allow you to explicitly define your starting and ending position, and as a consequence, our item will be pushed away if I increase the size of a nearby item, like item 1. If you don't care about anchoring an item into a specific position, then the span keyword is okay to use. Using grid row and grid column is good, but there's an even faster property. Grid area takes 4 values. The first is the starting line on the rows, the second is the starting line on the columns, the third is the ending line on the rows, and the fourth is the ending line on the columns. If I want item 3 to fill out the rest of the available space, I can give it the grid area with the starting row of 3, the ending column of 1, the ending row of 7, and the ending column of 7. I can also use the negative numbers that we see on our grid. So instead of 7 and 7, I could say -1 and -1, and this will work the same. This one property does the job of 6 properties, so personally, that's the one that I always use. Before CSS Grid, layering an item on top of another was painful. You had to use an absolute positioning and then try to position the item using the top, right, bottom, and left properties. But with CSS Grid, you just position your item where you want it to be, and if that happens to be on top of another item, then that creates layering. Super easy. I want item 2 to be right here, touching both the item 1 and item 3. To do this, I'll remove the grid row and grid column and use the grid area instead. The row starts at 2, the column starts at 4, the row ends at 4, and the column ends at 6. Our item needs to be on top. All we have to do is give it a Z index of 1, and now item 2 is layered on top of both item 1 and item 3.
Sure.
Now we see our items are filling out all of the available space except maybe for the top right corner. I'll make item 1 span all of the columns just to fill everything up. So now that all the cells are occupied, what would happen if I added another item in our HTML? Despite not having any room left, our grid added a new row for item 4. When items are added outside of the explicitly defined grid, this is referred to as an implicit grid. Notice how item 4 is smaller than the others. That's because the implicit grid doesn't inherit the values that we set in the grid template rows and grid template columns properties. But what we can do is add the grid auto rows property on our container. What this does is sets the size of the rows on any implicit grid that gets created. When I set it to 100 pixels, now our implicit grid has a row of 100 pixels. By default, our implicit grid added a row, but we can change this with the grid autoflow property and set it to column. Now any implicit grid that gets created will be created as a column instead. With the columns being the new default for our implicit grids, we can use grid auto columns to define the size of those columns and set it to 100 pixels. Now let's reset our grid by commenting out almost everything except the grid template rows and grid template columns. Inside the grid template rows and columns can go more than just pixel units. You can use ems, rems, percentages, etc. But there is one called the fractional unit that you should know about. I'm going to give the rows 2 values of 100 pixels and I'll give the columns 3 values of 1 FR. The FR unit represents a fractional value of the available space, and now we've got 3 columns, each one filling out the available space equally. If I set the second FR to 2 or 3, we see the column occupying more of the available space. You can also mix the FR units with other units without any issues. So for example, I can make the first value be 100 pixels. In general, you can mix and match values without any problems. When I resize the page, some of the items get way too thin. To set a minimum width, we can use the min-max function inside our grid template columns. I'll use the min-max function on the second column. It takes 2 arguments. The first is the minimum size and the second is the maximum size. I'll set the minimum size to 100 pixels and the maximum size to 3 FR. Now our item will stop shrinking whenever it hits 100 pixels. Another useful function is the repeat notation. I'll use this one on my grid template rows. The way the repeat notation works is by taking 2 arguments. The first argument is the number of times you want to repeat a value, and the second argument is the value you want to have repeated. We had 2 values of 100 pixels, so I'll set the first argument to 2 and the second argument to 100 pixels. Now the rows are just like they were before, 2 rows of 100 pixels, but now at least we aren't repeating ourselves. We can also add gaps to our grid with the grid gap property. If you assign it one value, then it will add gaps equally to both the rows and the columns. If you assign it two values, the first is the gaps on the rows and the second value is the gaps on the columns. I'm going to replace the values in my grid template rows for 100 pixels, 300 pixels, and 100 pixels. I'll also replace the values inside my grid template columns for 1FR and 3FR. I'm going to show you another way of positioning items in your grid that doesn't require keeping track of the line numbers. In my container, I'll add the grid template areas property. As a value, I'll give it 3 sets of single quotes stacked on top of one another with a semicolon after the last set of single quotes. Looking at my grid template rows, I see I defined 3 rows, and looking at my grid template columns, I see I defined 2 columns. We have 3 rows and 2 columns. Well, inside the first set of single quotes, I'll say header and header. Inside the second set of single quotes, I'll say main and aside. Inside the third set of single quotes, I'll say footer and footer. The reason I added 3 sets of single quotes is because I know my grid only has 3 rows, and the reason I added 2 values inside of each of the single quotes is because I know my grid only has 2 columns. Each set of single quotes represents a row and each value inside of them represents a column. Looking at my grid, we see the developer tools added the names we set inside the grid template areas in the appropriate position. Now all I have to do is give each item the grid area property and assign them the section I want them to occupy. I want item 1 to be the header, I want item 2 to be the main, I want item 3 to be the aside, and I want item 4 to be the footer.
I am never the same, but I am always myself.
Paradox Virtual Flower, the new refillable fragrance by Prada.
Когато учебното представление на децата е като това, вие имате нужда от това.
I'll change my account next time.
Now we see each item is occupying the section
I
we
couldn't even
assigned them
skip
to.
those.
By the way, this was just an example. I don't think I'd have one grid for all 4 sections in a real website. I'd probably have multiple different grids across my page for the various sections and components. Also, this way of positioning things is fun, but it makes layering items more difficult. It can be done though, it's just more difficult. We're almost done. I'll reset my grid by commenting out pretty much everything and set a repeat of 4 100 pixels on the rows and a repeat of 4 1FR on the columns. Our items are currently stretching both on the row axis and the column axis, and this is because on our container, there's 2 properties we don't currently have, but that in the background have a default of stretch. The justify items and the align items properties both have a default value of stretch. I can change them to either start, end, baseline, or center. Justify items align items on the row axis, so if I change justify items to anything else, like start, we see our items are at the start of the row axis, but still in the center of the column axis. If I change align items to anything else, like end, now our items are still at the start of the row axis, but are now at the end of the
is for the horizontal and align is for the vertical
column axis. These properties are affecting all of the items, but if we wanted to align items individually, we can use the justify self and the align self properties on the items themselves. So for example, if I wanted to overwrite the row alignment of item 1, I could use the justify self and set it to anything else like center. And if I wanted to also overwrite the column alignment, I would use the align self property. Maybe this one I'll set it to stretch. Justify items and align items were to align our items inside our grid, but we can also align the grid itself along the container. So for example, I'll clean things up by removing everything except display of grid, grid template rows, and grid template columns. I'll also add a height to the container of 600 pixels. I'll say that we have 2 rows instead of 4 and also 2 columns instead of 4. I'll also replace the 1FR with 100 pixels. Now we have a smaller grid in comparison to the container.
Okay.
We can align the grid with justify content and align content. They both take the same values: start, end, center, baseline, space between, space around, and space evenly. Justify content aligns the grid along the row axis, and aligned content aligns the grid along the column axis.
Right.
The last thing I want to show you is a cool trick for creating
It's good that we have a video at the end of this section, or like that just sums everything up.
a responsive grid that requires 0 media queries. That's right, responsive without media queries. Once more, I'll reset my grid. I'll set up a standard grid. The grid template rows can have a repeat of 4 100 pixels, and the grid template columns can have a repeat of 4 and a min-max of 100 pixels and 1 FR. If I resize it, it'll eventually break. To fix this, normally I would add a media query and change things based off the viewport width, but instead all I can do is in my grid template columns, instead of repeating 4 times, I can replace 4 with the autofit keyword. Now, when the items reach their minimum size of 100 pixels, the autofit keyword will make the items autofit and wrap onto the next row, creating a grid that is automatically responsive.
Cool.
And there you have it. If this
Really
video
cool.
helped you in any way, then
It was a
it
good
achieved
video.
its goal. Also, I would be really honored if you considered subscribing
Slaying
to the
the dragon. I think I heard of this
channel.
guy.
Hello.
Slaying the dragon. Cool. So we're done with that, and we have one last resource before finishing this section. And I quickly took a look at this website, and it looks very interesting. So let's start with it. This is about an interactive guide to CSS Grid. So it says CSS Grid is one of the most amazing parts of the CSS language. It gives us a ton of new tools we can use to create sophisticated and fluid layouts. It is also surprisingly complex. It took me quite a while to truly become comfortable with CSS Grid. In this story I'm going to share the biggest lightbulb moments I've had in my own journey with CSS Grid. You'll learn the fundamentals of this layout mode and see how to do some pretty cool stuff with it. Browser support, this is from 2017. Alright, sure. Mental model. CSS is comprised of several different layout algorithms, each designed for different types of user interfaces. The default layout algorithm, flow layout, is designed for digital documents. Table layout is designed for tabular data. Flexbox is designed for distributing items along a single axis. CSS Grid is the latest and greatest layout algorithm. It's incredibly powerful. We can use it to build complex layouts that fluidly adapt based on a number of constraints. The most unusual part of CSS Grid, in my opinion, is that the grid structure. The rows and columns are defined purely in CSS. Yeah, you're right, this website is awesome. During my Flexbox lessons, I was made to go there for some article. The site is just out of this world. Yes, I fully agree with you. Just like, look at this. I'm not even sure how he did that. What is that? Wow. So these are literally divs, but I think those are CSS animations. Yeah, it's you can see the transforms here, how he skews it, but that's awesome how he did that. Makes learning really fun. With CSS Grid, a single DOM node is subdivided into rows and columns. In this story we're highlighting the rows and columns with dashed lines, but in reality they are invisible. This is super weird in every other layout mode. The only way to create compartments like this is by adding more DOM nodes. In table layout, for example, each row is created with a tr and each cell within that is created using td or th. So for example, in this table we have a T body with table row of 4 like cells, and 3 and 3 in the other row as well. Unlike table layout, CSS Grid lets us manage the layout entirely from within CSS. We can slice up the container however we wish, creating compartments that our grid children can use as anchors. Even like the hashtags have little navigations, little animations, sorry, and when you click them it's so satisfying. I like this a lot. We opt into the grid layout mode with the display grid property. By default, CSS Grid uses a single column and will create rows as needed based on the number of children. This is known as an implicit grid since we aren't explicitly defining any structure. Here's how this works. Number of children. Like, see, this website is awesome. You can change the perspective, do it again. Implicit grids are dynamic. Rows will be added and removed based on the number of children. Each child gets its own row. By default, the height of the grid parent is determined by its children. It grows and shrinks dynamically. Interestingly, it isn't even a CSS grid thing. The grid parent is still using flow layout, and block elements in flow layout grow vertically to contain their content. Only the children are arranged using CSS grid layout. But what if we give the grid a fixed height? In that case, the total surface area is divided into equally sized rows. So for the parent, this time we give it a height of 300 pixels, and as you can see, the parent's height is still the same, but the more rows we get, the smaller they are. And we can again change the perspective. Pretty cool. Grid construction. By default, CSS Grid will create a single column layout. We can specify columns using the grid template columns property. So grid template columns 25 and 75%. Okay. Dashed lines added for clarity, like in the playground above. And throughout this tutorial, I'm using dashed lines to show the divisions between columns and row. In CSS Grid, these lines are invisible and can be made visible. I'm sure using some block magic here, faking it with pseudo elements. You can pop over to see the CSS tab if you'd like to see how. By using two values to CSS Grid columns, 25 and 75%, I'm telling the CSS Grid algorithm to slice the element up into two columns. Columns can be defined using any valid CSS length percentage value, including pixels, rem, viewport units, and so on. Additionally, we can also gain access to a new unit, the FR unit. FR stands for fraction. In this example, we're saying that the first column should consume 1 unit of space, while the second column consumes 3 units of space. But it looks exactly the same because this is like 25 and 75 pixels. Okay. That means there are 4 total units of space, and this becomes the denominator. The first column eats up 1/4 of the available space, while the second column consumes 3/4. The FR unit brings Flexbox style flexibility to CSS Grid. Percentages and length values create hard constraints, while FR columns are free to grow and shrink as required to contain their contents. Try shrinking this container to see the difference. So container width, there you go, with fractional units. Although like the first one has an image with it, so if it gets smaller than the FR, it will just contain the image. And you could argue that at 40% width, the second column, that should be 3 fractions, and the first one 1 fraction, the first one is bigger, but it is that way because it contains an image. If there wasn't an image, the first one would still be like 1 fraction. Let's see it with percentages. Yeah, that's about what would happen. Cool. So they're saying in this scenario, our first column has a cuddly ghost that has been given an explicit width of 55 pixels, but what if the comb is too small to contain it? Percentage-based combs are rigid, and so our ghost image will overflow, spilling out of the comb. FR-based combs are flexible, and so the comb won't shrink below its minimum content size, even if that means breaking the proportions. To be more precise, the FR unit distributes extra space. First comb widths will be calculated based on their contents. If there is any leftover space, it will be distributed based on the FR values. This is very similar to Flex Grow as discussed in my interactive guide to Flexbox. In general, this flexibility is a good thing. Percentages are too strict. We can see a perfect example of this using gap. Gap is a magical CSS property that adds a fixed amount of space between all of the columns and rows within our grid. Check out what happens when we toggle between percentages and fractions. So this gap is 16 pixels, and again the grid template columns are 1FR and 3FR, and with percentages Alright, so with percentages the second one gets, actually both of them get a little bigger, but they are overflowing the parent, so this red thing is an overflow. Alright, notice how the contents spill outside of the grid parent when using percentage-based columns. This happens because percentages are calculated using the total grid area. The two columns consume 100% of the parent's content area, and they aren't allowed to shrink. When we add a 16 pixels gap, the columns have no choice but to spill beyond the container. So when we're defining the percentages, we don't account for the gap. The FR unit, by contrast, is calculated based on the extra space. In this case, the extra space has been reduced by 16 pixels for the gap. The CSS Grid algorithm distributes the remaining space between the two grid columns. Alright, so we have gap versus grid gap. When CSS Grid was first introduced, the grid gap property was used to add space between columns and rows. Pretty quickly, however, the community realized that this feature would be awesome to have in Flexbox as well, and so the property was given a more generic name, gap. These days, grid gap has been marked as deprecated, and browsers have aliased it to gap. Both properties do the exact same thing, and they both have nearly identical browser support, around 96%, and so I recommend using gap rather than grid gap whenever you're working with Flexbox or CSS Grid, but there is also no urgency when it comes to converting existing grid gap decorations. And where do they get these percentages from? It's right here, 96 indeed. I wonder if that's like dynamic. I think so, because wait, yeah, I'm not sure. We definitely like have a span for that, but I don't know if they're doing any of that with JavaScript, for example. So anyways, implicit versus explicit rows. What happens if we add more than two children to a two-column layout? Well, let's give it a shot. I want to create a new row. Interesting, our grid gains a second row. The grid algorithm wants to ensure that every child has its own grid cell. It will spawn new rows as needed to fulfill this goal. This is handy in situations where we have a variable number of items, in example a photo grid, and we want the grid to expand automatically. In other situations though, we want to define the rows explicitly. To create specific layout, we can do that with grid template rows property. By defining both grid template rows and grid template columns, we've created an explicit grid. This is perfect for building page layouts like the Holy Grail layout at the top of this tutorial. This was the name given to the most common layout in the days of the early web: a header, sidebar, main content area, and a footer. So I was wondering about that, but if you can remember from last stream, we did an exercise where it was called like Holy Grail something, and it seems like this is the most common layout in the days of the early web. Okay, the repeat helper. Let's suppose we're building a calendar, so CSS Grid is a wonderful tool for this sort of thing. We can structure it as a 7-column grid with each column consuming 1 unit of space. This works, but it's a bit annoying to have to count each of those 1FRs. Imagine if we had 50 columns. Fortunately, there is a nicer way to solve this using the repeat function. We'll do the copy pasting for us. We're saying we want 7 columns that are each 1FR wide. Here is the playground showing the full code if you're curious. Calendars and accessibility. This calendar is a quick and dirty example of how we can use CSS Grid to create a specific layout. It isn't intended to be production ready. If you're looking to build a date picker, you should absolutely use an accessibility focused library like React area. Cool. Assigning children. By default, the CSS Grid algorithm will assign each child to the first unoccupied grid cell, much like how a tradesperson might lay tiles in a bathroom floor. Here's the cool thing though, we can assign our items to whichever cells you want. Children can even span across multiple rows and columns. Here's an interactive demo that allows us, that shows us how this works. Click, press, drag to place children in the grid. So, see how we can place children. It's cool. And we can drag to resize it. And it shows us the child class, like positioning. That's really cool. The grid row and grid column properties allow us to specify which tracks our grid child should occupy. Can I? No, I cannot like delete this. Let's see. So it's not editable. It's still very cool. If we want the child to occupy a single row or column, we can specify it by its number. So grid column 3 will set the child to sit in the 3rd column. Grid children can also stretch across multiple rows and columns. The syntax for this uses a slash to delineate start and end. At first glance it looks like a fraction, 1/4. In CSS though, the slash character is not used for division. It is used to separate groups of values. In this case it allows us to set the start and end columns in a single decoration. It's essentially a shorthand of this. Sorry. There is a sneaky gotcha here. The numbers we're providing are based on the column lines, not the column indexes. It will be easiest to understand this gotcha with a diagram. Alright. Confusingly, a 4-column grid actually has 5 column lines. When we assign a child to our grid, we anchor them using these lines. If we want our child to span the first 3 columns, it needs to start on the 1st line and end on the 4th line. Negative line numbers. In a left to right language like English, we count the numbers from left to right with negative line numbers. However, we can also count in the opposite direction from right to left. So they're saying grid column -2 and it will position it here, for example. The really cool thing is that we can mix positive and negative numbers. Check this out. So grid column, number of columns. When it's -1, it will automatically span to the end com. Notice that the child spans the full width of the grid, even though we aren't changing the grid column assignment arrow. We're saying here that our child should span from the first column line until the last column line, no matter how many columns are there. This handy decoration will work as intended. You can see a practical use case of this trick in my blog post, Full Blade Layout using CSS Grid. So we're at grid areas, and I'm going to take a short 10-minute break since we've already been reading for an hour. So I'm taking a 10-minute break to catch some fresh air, and I'll be right back with you guys. Thank you so much. I'll be right back. Alright boys, I'm back and ready to continue. It was a good break. Now we're back at grid areas. Alright, so time to talk about the coolest part of CSS Grid. Let's suppose we're building this layout. So header sidebar and main. What we've learned so far, we could structure it like this. So he's showing the code. He's positioning the items with grid column and grid row. This works, but there is more ergonomic way to do this. Grid areas, here what it looks like. So grid area sidebar. So in the parent he defines the grid template areas as sidebar, header, sidebar, main, and he just assigns child to grid area sidebar, header to header, and main to main. Like before, we were defining the grid structure with grid template columns and grid template rows, but then we have this curious decoration, parent, grid template areas, and where he defines the layout. Here's how this works. We're drawing all the grid we want to create, almost as if we're making ASCII art. Each line represents a row, each word is a cell, is a name we're going to give to a particular slice of the grid. See how it sort of looks like a grid visually. Then instead of assigning a child with grid column and grid row, we're assigning it with grid area. When we want a particular area to span multiple rows and columns, we can repeat the name of that area in our template. In this example, the sidebar area spans both rows, so we want sidebar for both cells in the first column. Should we use areas or rows and columns? When building explicit layouts like this, I really like using areas. It allows me to give semantic meaning to my grid assignments instead of using incrutable row column numbers. That said, areas work best when the grid has a fixed number of rows and columns. Grid column and grid row can be useful for implicit grids. Being mindful of keyboard users, there is a big gotcha when it comes to grid assignments. Tab order will still be based on DOM position, not grid position. It will be easier to explain with an example. In this playground, I've set up a group of buttons and arranged them with CSS Grid. So if we start tabbing, you can see the outline. From 1 it goes to 4, because as you can see in the HTML, 4 is after 1, then after that we have 6 and so on. It doesn't follow the visual order. But that's normal, I guess, because you just have to be careful how you structure your CSS and HTML actually. In the result pane, the buttons appear to be in the right order. By reading from left to right and top to bottom, we go from 1 to 6. If you're using a device with a keyboard, try tab. Alright, so we've done that already. You should see something like this. Yes, we did. It says the focus outline jumps around the page without rhyme or reason from user's perspective. This happens because the buttons are being focused based on the order they appear in the DOM. To fix this, we should reorder the grid children in the DOM so that they match the visual order, so that I can tap through from left to right and top to bottom. The reading order CSS property. The CSS working group is aware that this kind of a flow in CSS Grid, having to match the DOM order with the visual order, sort of defeats the purpose of being able to assign children to specific grid cells. A fix in the works is the feature of reading order CSS property. Should allow us to instruct the browser to ignore the DOM order and focus elements in the order they appear on screen. Unfortunately, this property is not yet implemented in any browsers as of September 2024, so this article is either quite recent or he's updating it regularly, which props to both. You can learn more about this property in Rachel Andrews' post solving the CSS layout and source order disconnect. In order to update this book and all of the articles, you have to be really you have to be reading the news and updating it all the time, which I guess he has a lot of likes. It's worth it, I guess. There you go. Let me spam up some likes. Alignment. Oh, you don't see it actually, but I was clicking this button right here. I just noticed. In all the examples we've seen so far, our columns and rows stretch to fill the entire grid container. This doesn't need to be the case, however. For example, let's suppose we define two columns that are each 90 pixels wide. As long as the grid parent is larger than 180 pixels, there will be some dead space at the end. We can control the distribution of space using justify content property, so this will position the grid. Start, center, and space between. This is very cool. Very, very cool. If you're familiar with Flexbox layout algorithm, this probably feels pretty familiar. CSS Grid builds on alignment properties first introduced with Flexbox, taking them even further. The big difference is that we're aligning the columns, not the items themselves. Essentially, justify content lets us arrange the compartments of our grid, distributing them across the grid however we wish. If we want to align the items themselves within their columns, we can use the justify items property. So justify content, let's say center, and we can say justify items. It's using stretch. We can use start and center. Stretch is the default one. Alright, that's pretty cool. How he's showing the examples. Alright, when we pop a DOM node into a grid parent, the default behavior is to stretch across the entire column, just like how a div in full layout will stretch horizontally to fill its container. With justify items, however, we can tweak that behavior. This is useful because it allows us to break free from the rigid symmetry of columns. When we set justify items to something other than stretch, the children will shrink down to their default width as determined by their contents. As a result, items in the same column can be different widths. We can even control the alignment of specific grid child using justify self property. So justify self, this is for the first item, I guess. I can put it to center, start, and so on and so forth. Pretty cool. Unlike justify items, which is set on the grid parent and controls the alignment of all grid children, justify self is set on the child. We can think of justify items as a way to set default value or for justify self for no grid children. Aligning rows. So far we've been talking about how to align stuff in the horizontal direction. CSS Grid provides an additional set of properties to align stuff in the vertical direction. So you have justify content to align the grid. So let's put it in center, justifying items to align the items inside of them, inside the grid. Align content will align the rows. So justify content will align the columns, and align content will align the rows. So this is even more thorough than my hey, after a long time MySQL coding. What is up, my guy? Thank you for joining once again. This is even more thorough than what my understanding was, but it's really cool that we can have this interactive perspective of how it works. So align content is for the rows and it aligns them vertically. Justify content is for the columns and it aligns them horizontally. Justify items is for the horizontal alignment of the items inside the grid, and align items is for the vertical alignment of items inside the grid. And this is pretty cool. I love this article. I love this website. Align content is like justify content, but it affects rows instead of columns. Similarly, align items is like justify items, but it handles the vertical alignment of items inside their grid area rather than horizontal. To break things down even further, justifying deals with columns, align deals with rows, content deals with the grid structure, items deals with the DOM nodes within the grid structure. So this is really important to understand and remember. Finally, in addition to justify self, we also have align self. This property controls the vertical position of a single grid item within its cell. Two-line centering trick. There is one last thing I want to show you. It's one of my favorite little tricks with CSS Grid. Using only two CSS properties, we can center a child within a container both horizontally and vertically. So we do place content center, place content start, and place content center. So he's placing the child and the rows and columns, or actually just the rows and columns. I see the child is stretched. Place content center. Cool. The place content property is a shorthand. Its syntactic sugar for this is justify content center and align content center. Alright, as we've learned, justify content controls the position of columns, align content controls the position of rows. In this situation, we have an implicit grid with a single child, so we wind up with a 1x1 grid. Place content center pushes both the row and the column to the center. There are lots of ways to center a div in modern CSS, but this is the only way I know that only requires two CSS decorations. Tip of the iceberg: in this story we've covered some of the most fundamental parts of CSS Grid layout algorithm, but honestly there is so much more stuff we haven't talked about. If you found this post helpful, you might be interested to know that I've created a comprehensive learning resource that goes way deeper. It's called CSS for JavaScript developers. Okay, there's like a course he has. A pretty cool sales page as well. He's a very good designer and developer probably. Alright, so this is just showcasing the course. I love the little details. Look at how his eyes change as well. Very nice website. Let me book this. I'll bookmark this because I'll definitely forget his name. Alright, but with that done, we're ready to mark this lesson complete and on to the next lesson, which is we're 91% complete. This is the final article before doing the project, so let's just see what it consists of. Read how is this MDN or CSS tricks. We have a video to watch, one more reading, and then in the additional resources we have MDN and this, whatever this is.
U-Track now comes with Writing Assistant, a JetBrains.
Sorry for the advertisement. This is 18 minutes, okay. Alright, so we'll probably be able to go through this as well, and then we'll see if we'll be able to start with the project. Alright, so using Flexbox and Grid, some may tell you that there is a debate on the use of Grid versus Flexbox and whether or not one is superior to the other. The reality is these are complementary tools that can work together, and each has its own piece in the world of CSS. Let's now know when you might want to use Flexbox over Grid, Grid over Flexbox, and when to use them together. So this is very important. Content first versus layout first design. A way to decide between Grid and Flexbox is to consider if your design starts from the content or from the layout. In content first design, you begin with clarity of how the content should be, and the layout follows. This is a great opportunity to use Flexbox. Its flexible nature gives you control over the behavior of items through logical rules, how they grow, shrink, their ideal size and position in relation to each other, all make the layout dynamic. While Flexbox gives you control over its content, the final layout is only a consequence, depending on the dimensions of the Flex container, or the general layout can change a lot. Okay. So in layout first design, you decide how you want to place, how you want pieces arranged, then fill in the content. That is when Grid shines. Defining Grid row and column tracks gives you full control of layout. Content in a grid can only fill the spaces of explicit or implicit tracks, so when you have an idea of how the big picture of a container should look like, Grid is the clearer choice. Content or layout first design do not force us to use either. So content or layout first design do not force us to use either Flexbox or Grid. Let's try laying out a one-dimensional set of items, a task many reserve for Flexbox using Grid. So they're just making a display grid with 3 1FR columns, grid gap of 10, and they're setting the child elements to mean height of 100 pixels and background of pink. Alright. It works and it looks absolutely beautiful, but imagine we would like to move these boxes around in the future, or for instance we wanted the third box to stretch in a second row so that the boxes didn't shrink too much to fit in only one. Both of these things would be possible in Grid, but if controlling the layout isn't our priority, Flexbox is more intuitive and fit for the task. So we have combining Flexbox and Grid. If you have one-dimensional content, Flexbox can make it easier to control how that content is positioned in a Flex container. If, on the other hand, you want to accurately place content on a complex layout in 2 dimensions, Grid can be easier to use. Say you want your overall layout to be a grid, but you want the grid items to act as Flex parents. This way the grid items can be moved around using the precise 2-dimensional placement Grid allows for, while also allowing the content inside the grid items to be capable of freely moving around using Flexbox. Check out this example from CSS Tricks. So what do we have here? So we can see the magic when we zoom out, I guess. Like the grid here of 1 column to column. What is that actually? Class layout in CSS layout is display grid as well, yeah. So we have 2 columns and the second row spans across both columns, so we can see this is intact whether we zoom or not. And the grid, the Flexbox items inside, I'm pretty sure those are, yeah, those are display flex, and they take up the whole space as we zoom out. Closing opinion: this lesson includes recommendations, not the right or wrong way of using Flexbox or Grid. Ultimately, it comes down to personal preference and what a developer feels is easier, or whatever the given task might be. At this point, you have both of these tools in your toolbox, and you got a sneak peek of how they can be used together. or one in place of the other. The best way to learn Flexbox and Grid is to build many projects with both of them and develop your own opinion about which one to use in different circumstances. So we have already the resources opened up and we're going to start going through them. So this first one is from CSS Tricks. Does CSS Grid replace Flexbox? And they say no. Well, mostly no. Grid is much newer than Flexbox and it has a bit less browser support. That is why it makes perfect sense if people are using. That's why it makes perfect sense if people are wondering if CSS Grid is here to replace Flexbox. To put a point on it, Grid can do things Flexbox can do. Flexbox can do things Grid can do. They can work together. A Grid item can be a Flexbox container. A Flexbox item can be a Grid container. Okay. Even though Grid is pretty new, we have lots of articles about it, including Getting Started article, an article, yeah, so on and so forth. If you haven't heard, the trumpets blaring March 2017 was the banner month for Grid. It was released completely unprefixed and ready to go in Chrome, Opera and Firefox and Safari. Even Edge supports it, albeit an older version of the spec, which you can get some support for using auto prefixer. I think this is no more. It seems a little complicated at first, especially if you're just starting to get a grip on the weird alien syntax of Flexbox. Now there is a whole other syntax to learn. Sheesh. Here are some things Grid is specifically better at than Flexbox. Making whole page layouts is better for that, even just considering layout performance reasons. So there are performance reasons, I guess. Can I open this up? Don't use Flexbox for overall page layout. So I think this is rendering the page but in slow motion, and as you can see Grid renders it faster, but that's just what I'm seeing from the video. I haven't read the article. Making literal grids like X combs and Y gap between them, homegrown framework stuff. Grid gap is wonderful as gutters are the main pain point of Grid systems. So I know the gap is already in Flexbox, so this article is quite old, but this is not a strong point of Grid over Flexbox anymore. Requiring less media query intervention with really powerful functionality like auto layout, min max, repeat and autofill. Here's a neat idea. And another huge one, Grid can position elements in 2 dimensions, both columns and rows. That's a first. Richo Andrew once made that very clear. Flexbox essentially for laying out items in a single dimension in a row or column. Grid is for layout of items in 2 dimensions, rows and columns. Alright, let's see some demos. Say we're building a, by the way, you can do horizontal and vertical layouts in Flexbox. You just have to define the rows and the columns in HTML, I believe. Say we're building a horizontal navigation component. That's the perfect use case of Flexbox because it sets content in only one direction. In Chris' demo below, you can mess around with those properties and just see how powerful Flexbox is. And here, as you can see, also we can work in 2 dimensions. It's just that it's all implicit, and this is using Flexbox. Flex container justify content set to center. We can set it to flex start, and we have something like the CSS Grid columns, where we define columns that will be with the auto autofill, but yeah, kind of we can use them interchangeably is what I'm ultimately trying to say, but I guess for some use cases it's just a little better to use CSS Grid or use Flexbox. But there are some instances where those Flexbox properties such as justify content or align items should be used in conjunction with grid properties. Take this demo for instance. So we have sidebar and content, and adds another sidebar content. First we've made a wrapper that is set to display flex. That way we can set a max width to our grid and justify content center to place it in the middle of the viewport. Then we can make our grid with the right number of columns. Okay, that's just the first step. Let's make that add take up the whole row of our grid. Well, we can do that by specifically targeting our there is a blank line without missing the rest of the children of our grid. My time is up, gotta go. Want to really watch the project. All the best work, man. Have a really great day. Thank you so much. I'll be streaming for like about an hour more, so I don't think we'll be able to get to the project honestly, but so you'll be able to watch it tomorrow. But thank you so much, my guy, for tuning in once again. Hopefully you have a great rest of your day and a really great Monday. Thank you so much, Supreme Overload. See you next time, my brother. Alright, so what we're saying with the code above is start this div on the first column and end on the very last column. That should look something like this. So grid column start 1 and grid column end 3. So as you can see, the add is now spanning throughout the whole width of the grid. Further, let's say that we always want to our add block be twice the size of our first row. We can totally do that. We just need the grid template rows property. Alright, that's the equivalent of saying there are 3 rows in our grid. Always make sure that the second row is twice the size of the first and third. In other words, we're creating relationships between rows and other rows, whilst also defining the number of columns in our grid. So as you can see, this add is twice as big. With CSS Grid we can set relationships horizontally with grid template columns and vertically with grid template rows, but at the same time Flexbox on the other hand is stuck doing either vertical or horizontal layouts with flex direction, but that doesn't mean we should ditch it. Potentially confusing a 2D layout with Flexbox, we can get a little confusing. What can get a little confusing is that it's not impossible to make multi-dimensional layouts using Flexbox. For example, we have with the flex wrap, it is possible to do it. Basically this enables us to make 2-dimensional columns, and if you can load up the example, as you can see, because we have 7 divs, the 7th one would span across it, and this like auto fit property. There are certainly rows and columns there, even a final element that spans multiple columns. It's easy to build and flexible. It's done through allowing flex wrap on the container, having the children's flex bases be 1/3 of the width of the container, and allowing flex grow to stretch children if needed. By the flex properties shorthand for flex grow, flex shrink and flex bases. It's not wrong, it's just one way of doing something like this, and you could probably make an argument for it being less intuitive and adaptive. Alright, potentially confusing a 1D layout with grid. Grid can do 2D layout, meaning defining both grid template rows and grid template columns, but it doesn't have to use both. Here's a demo of using it just to lay boxes in a horizontal row, so you can definitely do that. And they're doing that with 1FR, and this is the same as the repeat function here, just a little cleaner to use the repeat. This isn't wrong either. In fact, you could easily make the argument that this is easier to understand and more succinctly expressed than doing it with Flexbox. For example, no layout properties are needed on the child elements at all, but you could also argue that purely 1D layout is the more powerful in Flexbox, because Flexbox allows us to move those elements around easier, move them all in one side or another, change their order, space them out evenly, etc. About that nesting, one more time to lock in, this is good to remember. Grid items can be flex parents. Alright, the orange elements are grid items and flex parents. The red elements are flex children. So we have a grid with its children being flex items. And flex items can be grid parents. So the orange elements are flex items and grid parents, and the red elements are grid items. Okay, sure. So this was the article, pretty neat. Grid or Flexbox, how to decide. Let's put in the headphones for this one. And we are beginning.
Grid. We have two amazing layout tools available to us when we're writing our CSS these days. But wait, why do we have two layout tools? Well, the thing is, we all know when we should be putting on a pair of running shoes or dress shoes, and it's a little bit similar when we're thinking of Flexbox versus Grid. They are both things that create layouts, just like shoes are both things that we put on our feet, but they both serve different purposes and they have different strengths and weaknesses. So in this video, we're going to be looking at the differences between them, we're going to be examining them and seeing what situations which one works best. So when you're creating your layouts, it just simplifies that decision for you. And I'm going to give you a little sneak peek. It's not necessarily about one-dimensional versus two-dimensional layouts, at least not in the way that you might normally be thinking about it. Hello my front-end friends, and welcome back to yet another video. I'm so glad that you've come to join me once again. And if you're new here, my name is Kevin, and here at my channel I help you fall madly, deeply in love with CSS. And if I can't get you to fall in love with it, I'm hoping to at least make you a little bit less frustrated by it. And one of the ways that we can do that is by understanding which tool is the right one for the job. And we're going to be able to do that today by breaking down Flexbox versus Grid. So let's go and dive right into the code and take a look at them. Alright, so here we are in CodePen. We're going to look at a few different examples. This first example is more just to give us a general rundown on the differences between them and some of the default behaviors, and examine a little bit what they do similar, what they do different, and then we're going to break into other examples where I think it's more real-world situations that show where those strengths can come in and ways that you might want to use them. And so right here you can see I have a setup here with Flex and Grid, and basically the inner workings of each one of these is exactly the same. And so I have my Flex container has direct children here, and we don't even need these commented ones out, so let's just remove them. And so we have the exact same children in both of these, so we can just make sure we're on an equal playing field. And so if we come in here on the Flex container and we turn on our display of Flex, it will just make some columns. Flex does its Flex thing, and we get a bunch of columns. They're sort of responsive, they squish, they grow a little bit, they sort of do flexible things, as the name implies they will. And one thing that is important to know with Flexbox is every direct child will become a column, even if that means there'll be some overflow. And that means we can get some horizontal scrolling with Flexbox when we're not careful with it. So that is an important thing to take note. Whereas Grid, that won't really give you that problem by default, because when you turn it on, nothing happens. And this is because, well, with a Flex container, display Flex, the default here is a Flex direction of row, and that means the parent is a row. So the main axis is the row, and that means all of the children inside of it are becoming columns. But this is, we're choosing our Flex container here. So we're saying our Flex container is a row, so the children are becoming columns. That's the opposite behavior that we have in Grid, Where grid, the default behavior is a grid auto flow of row, and in this case it's creating rows and they're all stacking on top of each other. So we could actually get a very similar behavior to Flexbox by changing the auto.
I thought this is because we haven't defined any columns, but I guess he's right. It's because of the grid auto flow is a row by default, so it's not that we don't have columns, is that the content is automatically flowing into rows by default, and when we make columns, then we start to fill them up, and the rest of the content still goes onto new rows. So I guess that's correct. It's not that we haven't defined any columns.
Auto flow to column, and you'll notice they're almost the same. Not quite, but they're almost the same when we do that. And that's kind of interesting. You'll see they sort of grow and they shrink in a very similar way, but there's a few little strange differences between them that we're not going to get into specifically in this video, but it is an important thing to notice. And if ever we do this, this is going to lead to that situation where on both of them we are going to run into that overflow at one point because of just how these work. And if you are familiar with Flexbox, you might be going, well, I can prevent that behavior from happening by I have a display of flex. I don't want any overflow, so I can do a flex wrap of wrap. And just like that now, if things run out of room, they're still gonna, well, they're not really squishy anymore until we get to this point, but they do wrap around and they do this wrapping thing instead. And I'll get into why they're behaving this way in just a second. But let's go into grid and let's actually change this grid auto flow here. And instead of that, a similar behavior we could do here is a grid template columns. I'm gonna do the simple version first and then we'll make it fancier. The thing you'll often see here is 1FR, just like a few times, something like that, which will give us, in this case, 5 columns, and they're just 5 columns no matter what, and they're doing their 5 column thing, and that's it. And of course you can come on here and simplify that with a repeat of 5 1FR, and then we have 5 columns, or we could do 4, whatever you need. And there we go, we get the columns, and it's wrapping the content, but it doesn't sort of automatically wrap, right? We have these they're just sort of, we have 4 columns, we're stuck with 4 columns. Now there is a cool thing, and I'm not going to deep dive it in this video because I've talked about it a lot in other videos, and if you'd like any of those, there's more in-depth Flexbox and grid tutorials in the description below. But I will remind you about that at the end as well. But with this auto fit, what you can do is a min-max on here. And so on the min-max here, we can give it 2 values, the smallest we want them to get and the biggest we want them to get. So let's say they have a minimum size of 300 pixels, because why not, and a maximum size of 1FR. And now we're actually going to see that we get a different amount of columns, and they're going to wrap. It's not quite like the Flexbox behavior, but we sort of get that like wrapping behavior as they wrap down and they go down and down and down, and then back up this way. And this is a really important point to look at this Flexbox versus grid, and an important 2 things to consider right now are it's not necessarily about a 1D versus 2D layout like we often hear. And that's because if you look at here, we actually have Flexbox creating a 2-dimensional layout in a way up here, and then down here we have grid also making a 2-dimensional layout. And they're doing it in different ways, and they have different constraints in different ways that they're creating this. But it is important to know that Flexbox can wrap, and Flexbox can do what we think of as a 2-dimensional layout. But what's important with this is it's the way that we can control that layout that is 1-dimensional. And one way we can think about that too is each one of these rows is independent from the next one.
I saw in one of the articles we had to read, like Flexbox when wrapping looks like a brick wall, as you can imagine, like those are bricks, for example. And the grid, I don't remember what the analogy was, but it looks more structured.
So if we shrink down to here, like this column, here we have a very narrow column, here we have a big column, here we have an even bigger column, then we have some like this medium one, a big one, but like this column here is not looking at anything above it, anything below it. This row is independent from the row above it, it's independent from the row below it. Grid does not work that way. Grid is setting things up in a 2-dimensional grid. So the columns, they're locked in. This one only has this little short word in it, but that column is stretching to match the other columns around it. Or when we have 3, or when we have 4, the column in this row has to be the same as the column in this row. Now you can do things like span multiple columns, but it's still locked into a 2-dimensional grid, and you can't have these like in-between column-y things. Rows also work this way, where you can't get these in-between-y row things like you might think of in a masonry layout, even though eventually that is part of the level 3 grid spec, so we will get masonry layout, which will open up some interesting doors with CSS only. Hopefully it doesn't take too long to get there, but first we need subgrid, because that's the level 2 part of the spec. But I'm getting way ahead of myself. Let's not worry about that stuff too much right now. But I just want to look at here and sort of you can already see Grid's a little bit more structured and Flexbox is a little bit more flexible. And now let's come on to here and make a quick change. But there's an interesting thing is if I do want to change the way things are behaving here a little bit, I can't actually do a lot more work here. To be able to make more changes to the flex stuff, I actually have to come onto the children. And in this case, I'm going to do a flex container, the direct child, and select every direct child on there. And this is something that we don't generally need to do with Grid, unless you're going into like alignment within the cell. Whereas with Flexbox, you pretty much very often have to go onto the children and set different things on here. And so let's start with one thing that's kind of interesting, which is going to be to throw a flex grow on here of 1. And that's going to break things a little bit. But you can see like now, look at that, they're always filling up all their available space.
Yeah, it even more now looks like a brick wall.
So we don't get those on, like, that jagged edge we had before. They're all filling up the available space. We could even come on here and say a flex basis of 100%. Actually, that's not going to do very much. Let's come on here and say 33%. And that's going to give us 3 columns. But then this last one's allowed to grow, so it breaks bigger. And then, so you get these sort of interesting things here. It's, it's getting too small. It's sort of figuring things out on its own. And again, Grid is just this structured thing. It's really relying on what the parent is telling it to do, and the children are living within the grid that is being created. And what Flexbox is really good at, and that comes down to like before I set these on here, is intrinsic sizing and relying on the intrinsic sizing of elements. Because a lot of what Flexbox does is looking at that. And when I say intrinsic sizing, I mean how this item is shrunk down to be as small as the content inside of it. Just like this one, just like this one, just like all of these. They're shrinking down to the size of the content that is inside of them. That's the intrinsic sizing of an element. And there's other ways to have intrinsic sizing, but here, and then we can, here at one point they will actually start shrinking because they're running out of room. And this is one of those really nice things with Flexbox that the default behavior for it doesn't lock it in so much. Whereas with Grid, intrinsic sizing, there's ways of forcing it in there, just like there's ways of fighting against it within Flexbox, but the default way that it behaves is the Grid sets things up and the children in there, they fill up the space, or they take advantage of that space that the Grid is making available to it. So what does all this mean? When do we decide which one we should be using? And I want you to often be thinking, do I want to be relying on the intrinsic sizing of something? Do I want it to be as big as it is? Or do I want to have a bit more of a structured control from the parent's perspective? And so one common thing that we come up with is navigations, right? And here I've color-coded things just so we can visualize a little bit more what's happening. And I just have 2 identical navigations. One's in a header with a class of Flex, and one's in a header with a class of Grid. So we'll come on here and we'll say Flex, and we'll do our nav list that's in there, nav list. And let's do a display of Flex. And the nav list is my UL, so they all just go next to each other. And I purposely put this really long link just to highlight some things here. And we can come here and we can do a Grid, and then choose my nav list. And let's do a display of Grid. And if you remember, this does nothing, right? And right away, obviously, the Flexbox solution here just seems the better one, right? Because one line of code sort of got me what I wanted. Whereas here, I have to do more lines of code. Knowing the strengths of each one of them lets you go down the happy path. Go down the path of least resistance, where you're not trying to fight against what you're using so much. And so right away, I think, the Flex one, look at this, look at that, it's just working. And then we get some overflow, we're gonna fix that. But we get down to here, it's going, and then, okay, that's actually not so bad, right? Whereas with the Grid one, okay, let's try and get a Grid layout that actually looks okay. So we're gonna come in and then, well, I guess we could do like I showed you before, Grid auto flow column on here. And there we go. It is coming, but the spacing on these are kind of weird. And well, you know what? We do have gap with flex. So maybe we could do a gap of 1em here. And I don't know if I really need that gap on this one, because look at these big spaces that are coming. Again, default behavior. Maybe we could play with this a little bit to force the hand, but I'm still liking this one better than I'm liking this one. And okay, well maybe you say don't use the grid auto flow column. Do that trick you showed before where I did my grid template columns of auto fit, and then on there we do our min max, and let's just do a 0 1 FR, and you can see what happens with the 0 1 FR in here. And
zero.
We sort of go, it looks a little bit better, but look at this, like here we're running into a problem because look at all my columns are actually pretty much the same size now. And then this one's like super close, it's wrapping.
So 0 is a way to just put 1 FR there, or I don't quite get it.
On 2 lines, but like look how the spacing is unequal now because of the size of the cells are all the same, but that means the spacing is way off, and that's not really good. And once it does wrap on this, or we went to 0, maybe 0 would be a little much. Let's try 150 pixels maybe, just so it does wrap around. And then when they start wrapping, it's even worse here, right? Because that's kind of terrible. And what happens if we wrap again? Like, this isn't really wrapping the way I'd want it to. It's really creating this rigid grid system that I don't want. Whereas up here, if I just did a flex wrap of wrap, and nothing really changes, except now when I get to the smaller screen size, it just wraps. And it just goes down and it does what I need it to, and each navigation item is the size of itself, which is exactly what I wanted it to be. So by using the intrinsic sizing of each item, because I don't really want them to get big and bulky like I see what's happening over here, and like the vertical spacing, everything is off on this one, right? And whereas this other one, it just sort of works, and when I do run out of room, they squish down, and here I'm actually running into overflow issues again. Mind you, this is more narrow than you'll ever see, but you know what I'm saying, right? And so Flexbox, clearly, when we want this intrinsic sizing of things, is just so wonderful. And we just have these items that we want to go next to each other. If one's bigger, one's smaller, we want to keep those sizings. Flexbox is just wonderful. Grid, on the other hand, we can use in ways, and I'm not even going to get to like the big scale layout, because often for large scale layouts, it's wonderful. But one place, and I've talked about this before, so you might have heard me say this, but one place that Grid really excels is actually, again, when we want more of a rigid system from the parent. So let's say we want equal columns here, and I'm going to do it with Flex first, where you get a display of Flex on something, and then it's kind of awkward. We get a small column, a bigger column, and let's...
When inspiration strikes,
sorry,
creation right now.
I'll skip it right now.
Touchable, invisible.
Let's throw a gap on there just so it doesn't look terrible. And that works, but it takes more work now to get to the next step. And again, we can't do any more work really on the parent to get these to be equal. If I want these to be equal, I need to go on to the children then. So I have to go into my columns, and I have to sort of go against this intrinsic sizing. And this is really relying, this is because of the intrinsic sizing that this one is bigger than these ones. Because this has this really long paragraph in it, and this one has shorter ones. And that intrinsic sizing is really getting based on this big long paragraph here. So because it wants to be bigger originally, even once they get squished and they shrink down, it's still going to be bigger than these other ones. Until I come on here, and one common solution you'll see is putting a flex 1, and look at that. Now we get some more equal columns. And that, I mean, it does the trick, right? It's not a terrible solution. It solves our problem. Even though there are situations where this could actually maybe not solve your problem. If some of these have padding and some don't, you get these minor indiscrepancies just because of how the Flexbox algorithm works and stuff. But let's not even worry about that. It's just, I find like here I have to go on the parent, on the children. It's not that bad, but this is also a very simple solution. Whereas let's turn all of this off. And let's go look at it if I did a display grid, and we'll do the gap as well. And then we can just say I need 3 columns. So I just say 3 columns, and then I get 3 columns. And I'm saying they're 1 FR each. This can result sometimes in unequal columns, especially if there's like a really long word in one of them and not the other one. So it's not 100% of like a perfect solution. If you actually did a repeat with min-max on these, you might get something that's a little bit more consistent. But most of the time, you're not going to get a super long word or something that might be throwing things off. So a simple thing like this will probably, honestly, do the trick. And you just get 3 equal columns. And what I like about this is it's the parent that's controlling it. I can throw any children in there without worrying about that at all. And it's a really simple solution. And again, it's pretty much the same amount of CSS. We have 3 properties here. We have 3 properties here. And I guess a little bit more longer because you actually need 2 selectors for the Flexbox solution on this. But I just like that the parent is really in control and is creating a rigid layout that I can plug content into instead of getting a behavior from the parent and then have to get the children to behave the way I want them to. And I have to sort of make the children in charge, whereas here the parent is in charge of everything that's going on. So I really do feel that for structured layouts, Grid is a much better solution. And for those times where you want to rely on the intrinsic sizing of things, Flexbox is a much better solution, and that's whether there's wrapping or no wrapping. Here we have wrapping that's going on, so more of what you'd think is a 2D layout going on. And again, it's because of the flex direction and the control we have that we see Flexbox as 1D, whereas Grid is 2D, where we can control both dimensions on the grid a little bit of a different way. But you can make a 2-dimensional layout using Flexbox, and you can make a 1-dimensional layout with Grid. And one thing I want to go to before we get to the end of this, before we wrap things up, is I get asked a lot about if we can mix Flexbox and Grid, and people seem to think you get stuck with one or the other, but they work so well together. So here I've set up my grid that gives me my 3 columns here, and inside each one of these I have these guys, which are my tags. So if we just go take a quick look, I have my this card article that's right here, and in there I have a UL of tags, and I can just do my display flex and a flex wrap on them, and they get my little cards that show up here, and look at that, they work, and everything just works magically, because these, I want to rely on the intrinsic sizing of each one of those little tag things that are created, and then I want more of a structured grid style thing for the content itself. And I actually find that Grid is an easier one to get started with, even though there's a lot of properties that go on with it. They're a lot more straightforward, and there's a lot less worrying about it, because you're doing a lot less fighting against the intrinsic sizing of things and wrangling what's on the parent and what's on the child. But whatever the case is, and wherever you are in your learning journey, if you do want to get into one or the other, I have recently done videos on the easiest way to get started with Grid and the easy.
In the beginning I thought Grid was more complex, but now I see it as just more structured, more predictable, and although in the beginning I saw Flexbox as more intuitive and easier to learn, which probably was the case for me if I decided to do it this way after all, but I thought Grid would be much harder than when I began. So how do I remove this advertisement? There you go. None of that, please. Oh, they're like automatic. Wait, can I get rid of this? Like this whole thing. Yeah. Alright, that's a little better. So this article is about CSS Grid versus Flexbox, which should you use and when. No, I cannot stop the advertisement, sorry. Anyways, does this have a dark mode? I don't think so. Alright, both allow us to create complex layouts that were previously only possible by applying CSS hacks or JavaScript. Flexbox and CSS Grid share multiple similarities, and many layouts can be solved with both. Let's see if we can qualify when you should use Flexbox versus Grid. Industry recap: the CSS Grid versus Flexbox debate is currently the hottest topic in the CSS community. If you follow industry news, you have seen many great articles appear lately, such as they list the articles, but we'll skip over this. Okay, here's another take: 1 versus 2 dimensions. The most important thing to know as you're figuring out CSS Grid layouts versus Flexbox is that Flexbox is 1-dimensional while CSS Grid is 2-dimensional. Flexbox lays out items along either the horizontal or the vertical axis, so you don't have to decide whether you want a row-based or a column-based layout. A flex layout can also wrap multiple rows or columns, and Flexbox treats each row or column as a separate entity based on its content and the available space. On the other hand, CSS Grid lets you work along two axes, horizontally and vertically. Grid allows you to create two-dimensional layouts where you can precisely place grid items into cells defined by rows and columns. This is how W3C wants us to use Flexbox and Grid. However, practice frequently overrides theory, and not everyone is a fan of one-dimensional versus two-dimensional narrative. For instance, Chris Coyer made the following statement in his aforementioned article: "I'm not the world's biggest fan of 1D versus 2D differentiation of Grid versus Flexbox, only because I find most of my day-to-day usage of Grid is 1D. It's great for that. I wouldn't want someone to think they have to use Flexbox and not Grid because Grid is only when you're supposed to use 2D. It's a strong distinction though that 2D layout is possible with Grid through ways it is not in Flexbox." And this is how CSS works in real life. We can create two-dimensional layouts with Flexbox due to its wrapping ability, and one-dimensional layouts with CSS Grid due to its auto-placement ability too. Although Flexbox is originally not for building grids, it's frequently used that way. The best example is Bootstrap's Force grid system, which is based on Flexbox. All Bootstrap 4 sites out there makes use of Flexbox to accomplish two-dimensional layouts consisting of rows and columns, and there are other popular tools such as Flexbox Grid that do the same. When to use Flexbox versus Grid? The most common misconception regarding CSS Grid layouts versus Flexbox is that Grid is for full page layouts and Flexbox is for smaller components. This is not the case at all. All the authors mentioned above warn against this approach as it can seriously limit possibilities. You need to access each layout individually, assess each layout individually on a case-by-case basis to pick the better option in CSS Flex versus Grid. Focus on the content placement, CSS Grid. An important thing to note in the CSS Flex versus Grid debate is that CSS Grid focuses on precise content placement. Each item is on a grid cell lined up along both horizontal and vertical axes. If you want to accurately control the position of items within a layout, CSS Grid is the way to go. The W3 Docs of Grid module assert. It provides a mechanism for authors to divide available space for layout into columns and rows using a set of predictable sizing behaviors. Authors can then precisely position and size the building block elements of their application into the grid areas defined by the intersections of these columns and rows. With Flexbox, it's hard to predict behavior at certain viewports and you can get surprising results. Of course, you can set widths and heights of flex items or make use of the calc function, but then you lose Flexbox's main appeal, flexibility. This is not the case with CSS Grid. It has properties such as grid template rows and grid template columns and utilities like the fraction unit that let you precisely calculate everything. Hence, Grid is especially suitable for creating unusual layouts like broken, asymmetrical and overlapping layouts. CSS Grid also makes it possible to create responsive layouts without using media queries. The idea comes from Hayden Pickering, who recently published a YouTube video about algorithmic layouts. He introduces a simple grid technique that makes grid cells wrap and adapt to any viewport sizes. This was 5 years ago, but looks like an interesting video. Alright. Although the layout wraps based on the available space, it's still not content aware like Flexbox, as the content inside of the item doesn't flexibly stretch out. So you have long content stacked on top of each other, 1, 2, 3, 4 until 8, so on. So focus on content flow, Flexbox. On the other hand, on the other side of Flexbox versus Grid, Flexbox focuses on the content flow rather than the content placement. Widths or heights of flex items are determined by the content of the item. Flex items grow and shrink according to their inner content and the available space. This is how W3C's Flexbox docs explain the goals of the layout module. Flexbox gains simple and powerful tools for distributing space and aligning content in ways that web apps and complex web pages often need. In short, Flexbox enables you to allocate space and align items flexibly, which is why it's one of the main things to consider as you make a decision regarding CSS Grid layouts versus Flexbox. Let's see how Hayden's grid would look like with Flexbox. The following code adds a margin of 0.5 rem to each flex item. As Flexbox doesn't have a gap property, we need to use negative margin hack. So it has it has gap property now, so this is obsolete. As you can see below, the first flex item with the long content stretches out as far as needed. Alright. Of course, you can make fixed width flex items using the width or flex basis properties. However, if you do so, you lose Flexbox content awareness, which is the main reason for its existence. You can also see about that Flexbox treats each row independently. Different rows align items differently based on the amount of text inside of them. There are no columns here, and it's not a grid but one-dimensional layout. Flexbox allows you to decide how your content should behave when there is too much space or not enough space on the screen. I wrote about the topic in detail in my article about Flexbox sizing. Using the flex grow and flex shrink properties, you can achieve a completely fluid layout that optimizes the allocation of flex items at every viewport size. There are other typical use cases of Flexbox as well, such as centering items, adjusting the last items of list, sticking the footer to the bottom of the page, and creating responsive menus. You can find even more Flexbox usage examples in the MDN docs. So browser support, this is outdated, so I don't think we have to worry about this. Flexbox versus Grid, they have a video right here. How long is that?
Hey, welcome to a new tuts post.
I think we're going to skip this one. The Flexbox versus CSS Grid question doesn't have a clear-cut answer and depends on many different factors. Don't stick to one or the other, but always think through which serves your goals better. You can also combine CSS Grid and Flexbox to solve complex layouts like this cool cart UI. Yep, really cool indeed. So as you can see, the layout is grid, but the items themselves are flex items. Alright, this was the end of the article. We have an MDN article, and these are just some examples of Flexbox, I guess. So this one I don't think we need. We're just going to go through the MDN article. Now let me just get rid of the sidebars as I don't need them. Alright. I'm just going to take a quick break before going to read that, and I'll be right back. Just 10-minute break, very quickly. Be right back. Alright, I'm back. Thank you guys for sticking through. We're on the last MDN article of this lesson. We already completed the last lesson today, and seems like we're marking to complete. So we have relationship of grid layout to other layout methods. CSS Grid layout has been designed to work alongside with other parts of CSS as part of a complete system for doing the layout. In this guide, I'll explain how Grid fits together with other techniques you may already be using. Grid and Flexbox. The basic difference between CSS Grid layout and CSS Flexbox layout is that Grid was designed for layout in one dimension, either a row or a column. Grid was designed for two-dimensional layout, rows and columns at the same time. The two specifications share some common features. However, if you have already learned how to use Flexbox, the similarities should help you get to grips with Grid, which is the case indeed. One-dimensional versus two-dimensional layout. A simple example can demonstrate the difference between one and two-dimensional layouts. In this first example, I am using Flexbox to lay out a set of boxes. I have 5 child elements in my container and have given the flex properties values so that they can grow and shrink from a flex base of 150 pixels. I have also set the flex wrap property to wrap so that if the space in the container becomes too narrow to maintain the flex basis, items will wrap onto a new row. So this is how you make like a grid in Flexbox. Imagine you can see that two items in the image, in the image you can see that two items have wrapped onto a new line. These items are sharing the available space and not lining up underneath the items above. This is because when you wrap flex items, each row or column, each new row or column when working by column is independent flex line in the flex container. Space distribution happens across the flex line. A common question then is how to make those lines add up. This is where you want a two-dimensional layout method. You want to control the alignment by row and column, and this is where Grid comes in. The same layout with CSS Grid. Alright. A simple question to ask yourself when deciding between Grid and Flexbox is: do I only need to control the layout by row or column? Use Flexbox. Do I need to control the layout by row and column? Use Grid. Content out or layout in. In addition to one-dimensional versus two-dimensional distinction, there is another way to decide if you should use Flexbox or Grid for a layout. Flexbox works from the content out. An ideal use case for Flexbox is when you have a set of items and want to space them out evenly in a container. You let the size of the content decide how much individual space each item takes up. If the item wrap onto a new line, they will work out their spacing between based on their size and the available space on that line. Grid works from the layout in. When you use CSS Grid layout, you create a layout and then you place items onto it, or you allow the auto placement rules to place the items into the grid cells according to that strict grid. It is possible to create tracks that respond to the size of the content. However, they will also change the entire track. If you are using Flexbox and find yourself disabling some of the flexibility, you probably need to use CSS Grid layout. An example would be if you're setting a percentage width on a flex item to make it line up with other items in a row above. In that case, a grid is likely to be a better choice. We have box alignment. The feature of Flexbox that was most exciting to many of us, that gave us proper alignment control for the first time. It made it easy to center a box on the page. Flex item can stretch to the height of the flex container, meaning that equal height columns were possible. These were things we have wanted to do for a very long time and have come up with all kinds of hacks to accomplish, at least visually. The alignment properties from the Flexbox specification have been added to a new specification called the Box Alignment Level 3. This means that they can be used in other specifications, including grid layout in the future. They may well apply to other layout methods as well. In a later guide in this series, I'll be taking a proper look at box alignment and how it works in grid layout. For now, here is a comparison between simple examples of Flexbox and Grid. In this example, which uses Flexbox, I have a container with 3 items inside. The wrapper min height is set, so it defines the height of the flex container. I have set align items on the flex container to flex end so that the items will line up at the end of the flex container. I have also set the align self property on box 1 so it will override the default and stretch to the height of the container on box 2 so it aligns to the start of the flex container. Okay, sure. Alignment on CSS Grid. The second example uses a grid to create the same layout. This time we're using the box alignment properties as they apply to a grid layout. So we align to start and end rather than flex start and flex end. In the case of a grid layout, we're aligning the items inside of their grid area. In this case that is a single cell, but it could be an area made up of several grid cells. So the FR unit on flex basis. We have already seen how the FR unit works to assign a proportion of the available space in the grid container to our grid tracks. The FR unit, when combined with the min-max function, can give us very similar behavior to the flex properties in Flexbox, while still enabling the creation of a layout in 2 dimensions. If we look back at the example where I demonstrated the difference between 1 and 2 dimensional layouts, you can see there is a difference between the way that the two layouts work responsively. With flex layout, if we drag our window wider and smaller, the Flexbox does a nice job of adjusting the number of items in each row according to the available space. If we have a lot of space, all 5 items can fit on 1 row. If we have a very narrow container, we may only have space for 1. In comparison, the grid version always has 3 column tracks. The tracks themselves will grow and shrink, but there are always 3 since we asked for 3 when defining our grid. Auto-filling grid tracks. We can use grid to create a similar effect to Flexbox while still keeping the content arranged in strict rows and columns by creating our track listing using repeat notation and the autofill and autofit properties. In this example, I have used the autofill keyword in place of an integer in the repeat notation and set the track listing to 200 pixels. This means that grid will create as many 200 pixels columns as it will fit on the container. Okay, a flexible number of tracks, and this will use the autofit and min-max. This isn't quite the same as Flexbox. In Flexbox example, the items are larger than the 200 pixels bases before wrapping. We can achieve the same in grid by combining autofit and the min-max function. In this next example, I create autofilled tracks with min-max. I want my tracks to be a minimum of 200 pixels, so I set the maximum to be 1 FR. Once the browser has worked out how many times 200 pixels will fit into the container, also taking account for the grid caps, it will treat the 1 FR maximum as an instruction to share out the remaining space between the items. So if you just joined, this is quite abstract, but we've already gone through it today, yesterday and the day before, so I by now have a pretty good understanding, and so that's why I'm skipping the examples. With grid layout, we can create a grid with dynamic number of flexible tracks and have the items laid out on the grid, aligned by rows and columns. Grid and absolutely positioned elements. Grid interacts with absolutely positioned elements, which can be useful if you want to position an item inside of a grid or grid area. The specification defines the behavior when a grid container is a containing block and a parent of an absolutely positioned item. Okay, a grid container as a containing block. To make the grid container a containing block, you need to add the position property to the container with a value of relative, just as you would make a containing block for any other absolutely positioned items. Once you have done this, if you give a grid item position absolute, it will take as its containing block. It will take what? It will take the meaning as its containing block, the grid container, or oh my god, like I'm pretty much done with this article, to be honest with you. Like, this stuff, like, we've already gone through it multiple times, so at this point I'm just pretty done with it. So I get the gist of it. We can make grid containers, and whatever we don't know, we can always Google. So we mark this as complete, and let's just check the admin dashboards. So we just have the introduction. Now that you have plenty of practice using grid, we're going to build in a full dashboard design. For this project, use whatever tools you need to get it done, but try to lean on grid for the majority of the layout work. Go back to your lessons or practice assignment if you need a refresher. So we're making the dashboard, which looks pretty neat, but all of this, let me just look at some community solutions. Can I see some live previews? I think those are the most recent ones. So let me show you what we'll be doing. Admin dashboard, this one looks pretty good. Is it also responsive? Yeah, kinda. Yeah, sure, pretty good. What about this one? Yeah, this obviously not as pretty, but still the implementation is done. It's just he went a bit overboard with the shadows, with how large the icons are, with the sans serif font, so on. This one also very large icons, but you get the gist of it. It's they've done the task. This one is a little bit abstract, and I like how it turned out, and those are pretty similar. Yeah, so we're going to make something like this, but I will leave it. Thank you whoever subscribed, really appreciate you. But I will leave it for tomorrow, since I'm out of time. I need to go to work. So tomorrow we're finally doing the project, some hands-on experience, and either tomorrow or later today. But anyways, thank you for tuning in, and I'll see you guys later. Peace out. Bye bye. Thank you so much. Bye.